Hello, I'm here to demonstrate a little thing that I made. A little thing called, wait for it, Spotify set operations. All right, so let's dive into what that is. So we have this mathematical concept of a set. A set is a thing that is concerned with membership. So if I have an item, it is either in the set or it is out of the set. That is all we care about. So for example, if we have the set 1, 2, and 3, if I go and try to add like another 2 to the set, that actually cancels out entirely. We do not have duplicates inside a set. You're either in it or you're not in it. There's not like, there can't be two 2s in a set. There's just the single copy of a 2. The other thing about sets is that order doesn't matter. So these two sets, as I put here, they're completely equal because they have the same members. So if we have another set like 3, 4, 5, then these sets would be unique. They would be different from each other. And then, now that we know what sets are, we can do operations on those sets. So set operations are very nicely illustrated by Venn diagrams. So we have the intersection up here, which is give me the items that are in sets A and B. So they have to be in both sets in order for it to come out in an intersection. There's bottom left here, the union, which is, you can kind of think of it as just addition. So give me everything in A and everything in B, put them together. There's this symmetric difference, which what that does is it gives you everything in A and everything in B except the things that are in both A and B. So you just get the, as you can see, the outsides there. And then you can also get A difference B or A subtract B, and that's going to give you everything in A except for the things that are also in B. And so, for example, if we were to return to this example right here, say we have the set 1, 2, 3 and the set 3, 4, 5. If I wanted to get the intersection of that, I would just get a single item. I would get this set that contains 3, because 3 is in this set and it is in this set. So the intersection would yield this. So I'm just going to type that here. Intersection. Ta-da. Now, if we were to get the union, we would get union, new set, we get 1, 2, 3, 4, 5. Like I said before, there are no duplicates, so we don't duplicate the 3. There's only 1, and this gives us the ones that are in both. So that gives you a little bit of an idea of what set operations are. Now, how does this pertain to Spotify? Well, what if we viewed Spotify playlists as sets? Can we do something cool with that? Yes, we can do very cool things with that. So I'll just show one thing here. This would take you a lot of manual labor if you didn't do what I did. I created a playlist here called Mega 8, very aptly because it has the maximum number of songs on Spotify, 11,000 songs. And I made this in, well, a couple of minutes, actually, because of the program I made. It makes it super duper easy. Now, there was, I found this out after I made it, but someone actually made something quite similar. In fact, it basically does the exact same thing. But the only thing, there's actually quite a big limitation with this version is it only allows you to work with 2 playlists at a time. So if you wanted, for example, to add, if you wanted to add 50 playlists together, you would have to run this program 49 times. You would have to add playlist 1 and 2, take the result, add it to playlist 3, take the result, add it to playlist 4. So you'd end up running it 49 times to add all of those playlists together. With my program, you only need to use it once. And I will show you how we do that. So I have a previous run that I did there. We'll just ignore that. So we're going to do a playlist search. Playlist search. I don't know if you can see that, but we got some text up here. I don't think I can make it bigger, unfortunately. Sorry. We're going to do playlist search, and we're going to search Jacob Collier because he is amazing. So whenever you do a playlist search, you get back the top 50 results. You get the name of the playlist, you get the person who created the playlist, and you get the ID. The ID is what we're actually searching for here. So how do we turn this into something useful? We take all of the text, we paste it into our editor, and then through the magic of this, multiple cursors, we can go to the end of every line. We can select the last word on every line, and we can cut it out and paste it. And boom, look at that. We have a list of all the IDs. Now we're 2/3 of the way there. The last thing we have to do is put them all on one line. And again, multiple cursors saves us again. Just do a backspace and boom. Now we have all 50 playlists on one line. So we're going to take this. We're going to do Python free CLI -- playlist IDs. And we're going to paste in our list of IDs. Now the program is going to spit out all of the songs that are in all of these playlists. And so if we wanted to, if we really wanted to make sure that everything was tickety-boo, we could go through and look through all of these and make sure. But if you're combining 50 playlists together, I don't think you're going to check every single one. So then we get this symbol map. So we have A represents this playlist, B represents this playlist, all the way up to *X. And so basically this thing, whenever it runs out of the alphabet, it just puts a star in front. So if you had like, I don't know, 150 playlists, you get like ***A or something like that. I have actually tested with 150 playlists and it works. So that's pretty cool. So now we enter an expression with all of these. And so we can actually, if we're just going to combine them all, it's actually very simple. We just do what we did last time. We use our multiple cursors superpower. We're going to select the first word in every line. Now, unfortunately, we get this little bugger, but get rid of that. Now we have all of the playlist symbols. Now we're going to do, again, the same trick. Man, multiple cursors is a godsend. Boom. Now we have all of the playlist symbols on one line. And so back to our set operation example here, we're going to do this, the union. So it's going to add all 50 playlists together. And what symbol do we use for that? Well, right here we see it is the beloved pipe, or I don't know, whatever you want to call it, the bar or something. It's better known as the pipe. It's just a long top to bottom boy. Boom. So now we have all of these symbols union together. We have the pipe in between all of them. Now we just take this and we put it in as our expression. The program is going to ask us, hey, this is the playlist that we got. It's got 889 songs. Would you like to create it? Yes. Name the playlist. We're going to do test 01. And if I go to my Spotify client over here, ta-da, you're going to see at the top we have test 01, and we have all of the songs, and predictably most of them are by Jacob Collier and some other artists mixed in there that I imagine have a similar sound. So that is a quick demonstration of combining 50 playlists with this program in one go. And if you wanted to, you can actually import albums as well. So for example, if I wanted to add Yeezus to this playlist that I just created, well, let's just do that really quickly as an example. Do album search, and then we'll put in Yeezus. And then we'll go up to the top one, say here, Yeezus by Kanye West is this ID. So we will go back to the massive example we had before. We're going to do album IDs. I'm going to paste in Yeezus. And it's going to do the same thing it did before, but now there will be an extra symbol that is dedicated to Yeezus, and we'll see that here in a moment once it finishes. There we go. Yeezus is *Y. So if we just do *Y at the end of this, paste that in. Come on. This is not what I... Computers, they work when they work. And boom, now we have a new playlist. And as you can see, there are about 10 more songs than previously. And that is because, well, there is Yeezus test. And now if I bring over my Spotify again, we go Yeezus test, and we go album. We have, where's Y? Yeezus, ta-da! So we injected Yeezus. Now, if you wanted to do the opposite, if you wanted to make sure that an album was not in your playlist, I could have done a subtraction. So it'd be like, make sure there is no Yeezus in my playlist, and you put a little subtraction symbol. So if you want more information on how to set this up, I might do a video as a guide for setting it up. It is a little bit of a process. Obviously, it's not the most user-friendly thing. You have to use the command line. Ooh, spooky. It's actually not very spooky. It's super duper useful. So yeah, I might do a video in the future, but a link will be to this in the description. That's Wave Commander Spotify set operations. And yeah, I'll probably make another video detailing how to set this up. But it's not that bad. And so this program leverages the Spotify web API, and you can actually do, as you can see here, a whole lot of things. Basically everything on Spotify has an API endpoint, so you can do things very cool programmatically with it. So we use primarily the playlist and the albums API and the tracks API. But what's really cool is, if you've never seen this before, you get to see the kind of things that Spotify generates with AI. You can see get the audio features for tracks. They have run AI on the entire Spotify library, some 30 million songs or whatever. I don't know if it's up to maybe 60 million or something like that now. But so you can have characteristics like danceability. We are 73.5% confident this is a very danceable song. 57.8% energy. What key it is in, the loudness, like it just goes through and it analyzes every single song, and you can get that data from the Spotify API. So if you wanted to create your own AI recommendation system, you could look through every song and what features it has, and then the AI could go from there. Yeah, so that's a little introduction to my tool, and just a broader introduction to the Spotify API in general. You can do super duper cool things, and I'm sure I'm going to do more in the future. But yeah, so links in the description, of course, and I will see you later.